Hello guys, welcome back to Med Zone African Motives. Still on our engineering science N3, working on hydraulics. This is November 2023 exam on question number 6, where we are given the first part of the question to state the Pascal's law in words. So take note, they need this in what? In words, all right? So remember, that the Pascal's law is all about the pressure that is being applied in an enclosed system, and it must remain the same throughout. All right. So let us just have this properly. Let us just 6.1. So it states that all right, that if the pressure, so we'll be talking about the pressure in that case, all right? If the pressure is applied, all right, if the pressure is applied on an enclosed system, all right, gonna have this on an enclosed system, the pressure will spread evenly. So the pressure here will spread evenly. All right, will spread evenly like that. All right, throughout. So it's just gonna be through the enclosed liquid. Through the enclosed liquid. All right, that's through the enclosed liquid, or it can be a fluid. Or it can be a fluid, and is the same. And is the same throughout. All right, and it is the same throughout. So that is the idea of the Pascal's law. It states that if the pressure is applied on an enclosed system, the pressure will spread evenly through the enclosed liquid or the fluid that you're given there, and it's the same throughout. Okay. That's the idea of our part. And 6.2, we are given that the diameter of a ram of a hydraulic press, all right? So take note there. We are dealing with a hydraulic press in that case, and we understand that it consists of the ram and the plunger on the other side, all right? So you'll be having something of this nature, where here there is the weight that is supposed to be taken up. The plunger is we've got the force here on the plunger that is being applied to take this weight up so that it raises this weight up on the ram side. All right. So there we are given that the diameter of a ram press is 600 millimeters. So we've got the diameter of the ram in that case. All right. So that's 6.2 6.2. So we've got the diameter of the ram, capital letter D, that's given as 600 millimeters. So it's just going to convert to meters, divide by 1000 or multiply by 10 to the exponent of -3. That will be 0.6 in meters. All right. So this is from what? The ram. And on the plunger side, the diameter there is 240 millimeters. So this is from the plunger. The diameter is 240 millimeters. Again, multiply by 10 to the exponent of -3. That will be 0.24 in meters. All right. So the question was that calculate the ratio of the forces that we're going to have of the hydraulic press, the ratio of the forces. Okay. So on the ratio of the force, we're just given the diameter, and you wonder to say, how can I have this from the diameters only? All right. I want you to check this. Let's hopefully they have got this formula here. All right. There is this formula for the forces. All right. So unfortunately here, they did not mention about that. They just gave us for the pressure, for the volume, for the area. All right, no problem. Let me just write this formula for you. It's either way. I don't know how you're going to have it, but you can have it from the side of the ram is the force of the ram, which is the weight that we have on the ram. All right, so you're just going to have as W or F, capital letter F, over the diameter of the ram is equal to the force on the plunger over the diameter squared. This is D squared. So this is the ram side, and this is the plunger. All right. So that is the idea there. So meaning to say, we can play around this way that what we want. We can even start with the plunger side. F over D squared is equal to F on the ram over D squared on the way that you want. All right. So as we need the ratio like this to say F on the plunger to the F on the ram, F on the plunger to the F on the ram, no matter way. So if we take the ratio of force, it's going to be F over this, because this one is smaller compared to that one for the ram. So it's going to be F on the plunger to the F of the ram. So that is F over F of the ram is equal to the same way that we took. It's going to be this way again. So it's going to be D squared over D squared. So this is equal to D squared over D squared. So it's the same way. If you say this over this, then it's going to be this one over this one, all right? If you say this over this, then it's going to be this over this, okay? That is the idea of the question. So you can fill in and substitute. So it's F over F, which is the ratio of the forces, all right, is equal to the diameter squared on the ram, which is this on the plunger, sorry, small letters for the plunger. So that's 0.24 squared over D squared from the ram, which is this capital letter. This one is for the ram, which is 0.6 squared. So that will be a 0.6 squared. So that's it. The ratio of F over F is going to give you so that's 4 over 25. So you're going to get 4 over 25 from your calculator. So that is the ratio of the forces, or you can write it as 4:25, which is the force on the plunger to the force on the what? To the force on the ram. On the ram, you can also use W for that to represent the weight, all right? Or you can use capital letter F. It's up to you on your presentation. Okay, so that was the idea of the question. We need the ratio of the forces, which is this one. That's the ratio of the forces, all right? Let's consider the other question, okay? So on the other question, 6.3, we are given here 6.3, that's a pump needs to pump all water from a circular dam. All right, this is this question is very, very important. It's unfortunate that I don't think we covered that type of a question before on our preparations, but it was important that we had covered, if we covered that. All right, anyways, this is what this is how you answer this type of a question. You are given that a pump, it needs to pump all the water from a circular dam. So we have got a circular dam that we have in this case, all right? So it is supposed to pump the water out of the dam, this pump. So this circular dam, according to the dam, this is what we have. It has a diameter, the diameter in this case, all right, so this implies of the dam, the diameter of the dam is 1,500 centimeters. So if you divide by 100, it's going to be 1,15. Yeah, it's going to be 15 meters there if you divide by 100, all right? So that is the diameter in meters, all right? Then the depth of water in the dam, we are still in the dam there, which is the height down here, the dam. So you can take this as the height, which is the depth of water, 500 centimeters, divide by 100, which is 5 meters. So this is implying to the dam. So the water now must also be pumped through the height of, this is now for the water that is to be pumped out. All right. So here we are considering what is going to happen on the water. So the water is supposed to be pumped at a height of what? At a height of 450 centimeters, which is divided by 100. That will be 0.45. Right? So that's 0.45 in meters. All right. If we divide this by 100, 4.5, no man. That's 4.5, isn't it, guys? This will be 4.5. If we divide by 100 at this point, it's going to be 4.5, all right? So this is 4.5 here. So the height is going to be 4.5 in meters, all right? So now at this point, I want us to be careful at this point that we are having. For this water that is to be pumped out, it has got its own density, all right? The density of water, if you've forgotten, just check from your information sheet. We are given this, all right? So I just want to check if I inserted this here. All right, let's hope, yeah, okay, here. I inserted these values. All right, so I want you to check for the density here of water. If we are to check here, all right, I need the formulas, not the formulas. All right, here, let's check the density of water. If you've forgotten, you can check here the density of water. That is 1,000 kilograms per what? Per cubic meter. That's why we are talking about in meters there. The units are supposed to be in meters because this is taken per what? Per meter. All right. So we're gonna have this. All right. That is the only thing that we need here. So let's check on this part here. We're gonna need, it's like I said, you're gonna need the density of water. So we've got the density of water there, which is 1,000 kilograms per what? Per cubic meter. All right, so this is the information of what? Of the water. So the question was that, I want you to understand this. Calculate 6.31, the work done by the pump. Take note here. The water must be pumped through what? A height of 450 centimeters. The water must be pumped to this. So meaning to say we are talking about that height. What is going to be the work done at that particular moment? All right. So that's our 6.3, isn't it? 6.3 here. All right. So we know that work done is equal to, we can consider the work done from the pressure and the volume, because here definitely going to need the volume and the pressure. So that is pressure times what? Volume. So where are we going to have the pressure? From the water here. All right, we're going to calculate what? The pressure. So from our water, we are going to calculate pressure. So we're going to calculate P, which is the pressure from where? From the water. All right. So that is the pressure. Remember, pressure is equal to the density times the gravitational acceleration times the height, rho GH. All right. So that is the pressure is the density of 1,000 kilograms per cubic meter times the gravitational acceleration from our information sheet. That's 9,8 times the height in meters, which is 4,5. So take note of the information. We are supposed to take note of what are we considering. What are we using? All right. What are we considering? That is the most important part. All right. So this will give us the pressure, which is 44,100 pascals. All right. Remember, pressure is measured in what? In pascals. All right. So that means in that case, we are going to have this in pascals. Yes, you can write kilopascals if you want to convert to kilopascals, but just leave it like that. So we've got the pressure here. What we need is the volume. So where are we going to obtain the volume? From the dam. The dam is the one that will give us the volume here. So remember that the volume, if you are given the diameter and the height, so you're going to have the volume from the dam in this case. So the volume of the dam is equal to the area times the height, which is the area. It's a circular dam. So the area there is pi d squared over 4 times the height. All right, so that's pi times d squared, the diameter in meters. That's 15 squared over 4 times the height of the dam, which is 5, which is the depth of water in the dam. That is the one that we are considering. All right, so this was going to give us something like 3,529,938, so like that, which is going to be 573 to 3 decimal places in cubic meters. So we've got the volume in that case. So taking this into consideration from the work done, this formula that we have written here, we said the work done is going to be the pressure that we obtained. This is our pressure, which is 44,100 times the volume. All right. So you're going to multiply to the value of the volume that we have, which is 800 and what? 883,573. So this is we're gonna multiply to the volume, which is 883,573. All right. So that is the idea of calculating this type of equation, and that was gonna give us something like that's 389,655,69,3, which is measured in what? In joules. So you can even convert to megajoules in that case. all right, if you multiply by 10 to the exponent of -6, you're going to get 38. That will be 38,965. That answer will be in megajoules, 965 watt, which is going to be 966 in what? In megajoules. So you can just convert these two to megajoules, all right? So that was the idea of what? Of the question in that case, all right? So you have to be very, very careful how you attempt your questions, all right? How you attempt your questions. You are supposed to be very, very careful, all right? So that was the first part of our question. We're gonna move on to the other part where now we are given, let's check. Now they need us to calculate the power required to empty the dam within 6 hours. We're given the time frame to empty the dam. All right, as we know, we have got the work done, so it's easier for us to calculate the power. That's 6.32. Since we have got the time, we are given the time 6 hours in that case. And we know that the power is simply the work done over the time taken, and this time taken is supposed to be in what? In seconds. So that means the work done, which is 38, that's 38,966 megajoules. That's times 10 to the exponent of 6 over the time in seconds. Remember, 1 hour is 3,600 seconds. 1 hour is 3,600 seconds. Know your conversion. You are supposed to know your conversion or the conversion of units from one form to another. So meaning to say the time that we are having in hours in this case must be converted to what? To seconds. So it's gonna be 6 times what? 3,600 in seconds. So this will be in what? In seconds. So these are joules. Remember, power, it's work done per second, joules per second. So this is gonna give us something like 10. So that's 18, not 10, but 18. So that's 1803,9814, something like that, which is joules per second. Like I said, it means the watts, right? If we divide by 1,000, that's 1,8039. So it's gonna be a 4 like this in what? In kilowatts. That will be kilojoules per second, which simply represents what? The kilowatts. Just like that. Just like that. So you need the information, formulas that are needed, all right, to answer a particular question. You need to properly present your work. So let us also confirm with our calculators. Are we getting the same answer? You know, guys, we are human. How we use our calculators, we can just make a simple mistake on our calculator, then everything becomes wrong. So also confirm with your calculator if you're obtaining same values. All right, let us check the last part of the question. There they wanted us to illustrate by means of a sketch the following terms with a reference to a centrifugal pump, a suction head, static head, and a delivery head by means of a sketch. So they just want us to draw or to present a centrifugal pump, but consisting, as we know, that it must consist of this, the suction head, and so forth and so forth. All right, so that's a sketch here. Just gonna have something of this nature. Let's say our pump is connected this way. All right. Okay, just gonna have this is a sketch, guys. All right, you can draw something that is better than this. All right, so that is our centrifugal pump in this case. All right, so at this point we're gonna have two sections, the one on top as it is delivering here on top. So you're gonna have the delivery head. So on top, that's your delivery head. Then bottom here, that is your suction head. So this is our suction head in this case. And the wall of this part here, as it is, represents our static head. So this is the static head. And we know that the combination of this gives us the static head. The static head is equal to the sum of these two, which is the suction head. So it's going to be the sum of the suction head plus what? plus the delivery head. All right, plus the delivery head. So that is the condition of our question. Okay, just like that. So that is our centrifugal pump in that case. Okay, 3 marks for that. So 14 marks, everything. So you see, these questions, they do repeat. Sometimes they just ask you to write the equation which connect this, or they can say write the equation for the delivery head in terms of these. Meaning to say you have to make the delivery head the subject. They can even ask you to make an equation for the suction head. You just have to make the suction head the subject of the formula. From our mathematics, we can make anything the subject of the formula. All right. So that's it, guys. We just have to work with more questions, like I said, preparing ourselves for the exams ahead of time.